Today we're going to be looking at section 8.5, shifting and reflecting graphs of functions. So the first example says sketch the graph of f at x equals x squared, and that's one of the parent functions. So we know if x is 0, we plug 0 in and we get 0. So 0, 0 is included, and we know it's a parabola going up. It looks like a smile. So that is the graph of f at x equals x squared. What happens when we add 3? So we have this new function g at x equals x squared plus 3. Well, that just moves it up the y-axis. And so I'm going to put a dot there on 3. It still looks the same. Looks like a smiley pointing up. In example 2, we're given this sketched a graph of the absolute value of x. And we know if we put 0, 0, we get, if we put 0 in for x, we do get 0, which 0, 0 is included. So the absolute value graph looks something like this. Looks like a V. Well, then what happens if I put minus 3 inside the absolute value? Well, that shifts it this way on the x-axis, and oddly enough, it doesn't go over to the negative, it goes here to the positive 3. Still looks like the same graph, looks like a V. It's just shifted over to 3. Sketch the graph again of f at x equals x squared. We know from the first one that it looks like a smile going open like that. So if we have this smiley, that is the graph of x squared, what happens when we're doing all this stuff? Well, this negative 2 on the inside of the parentheses actually shifts it to the right 2, and that positive 3 on the outside moves it up to 3. So right there is where we start, and we still make our smiley face parabola. And so we have that. Again, the shift is negative 2 when we're doing x. It's always the opposite. So it's at positive 2. But then when it's on the outside, it's an actual shift on y of 3. So we went over 2 and up 3 for our vertex of this function. Going on to example 4, again, they're asking us to do that parent function. So we're going to put that in here. There's our smiley, and that's the parabola x squared. What happens with our new function g at x is a negative x squared. A negative on the outside of the x squared just flips him over the x-axis, and we have this graph. So that is the graph of a negative x squared, and so it turns into a frown. It looks like a frown, but it really is just flipping it over the x-axis. Sketching again, we're going back to the absolute value, but it has a negative out in front of it. So it is flipped over the x-axis. We know that negative out front now means I flipped the function over the x-axis, and there it is. Then what is this? Well, we said that is positive, even though it's negative on the inside. We have to go to the right. So we'll go to the right 2 and up 3. And there we are. And it's still the absolute function. So it looks like a V and coming down something like that.